the edge of the mirror between where the hump is, where the raised zone turns into the turned edge, and move it back and forth a little, and that'll tend to reduce the turned edge relative to the profile of the entire mirror. And you can actually treat any raised zone in that way just by knowing where it is, by using the values you get from the Coude screen. I call it like the Coude mask on the Foucault test. You find out where the high areas are, and you can use the edge of the tool as a sort of a carpenter's plane, you might say, to plane off the high areas as you go around. By the way, at the end of polishing, because I had the mirror on top, there was no astigmatism that I could detect. The optical surface was what you call a perfect figure of revolution. That is, if you take a diameter this way and then compare it with a diameter that way or any other diameter, the profile is exactly the same. There's no twisting of the mirror or anything like that. It's just a nice even. If there's a defect, it'll come up as a ring, rather than as a hump here and no hump there. It's symmetrical with this. All the defects are circularly symmetrical with the center of the mirror. So that's what you want. That's a very easy defect to correct. So theoretically it is anyway. Haha. So I'm just going to let that cold press for another minute. Maybe push down on it. Kind of shift it around. And you'll see me polishing a little bit more. As you can see, there's not too much mystery to figuring a mirror accurately. Like this method I'm doing now has the potential of at least getting a reasonably good result. Good enough for low and medium powers. You know, you don't need to figure a large mirror quite as accurately as you do a small one. So I'll still get good images at 200 or 300 power with it if I figure reasonably carefully. Of course, I'm hoping for better than that. Another possibility is if I get this fairly accurate, but not too accurate, and any defects that are left are of shallow curvature, like they're not too badly deformed, not sudden changes of slope. Theoretically, I should be able to correct for them by making appropriate corrective steps on a Cassegrainian secondary and end up with a perfect image. The Cassegrainian secondary should be able to compensate for slight errors in the primary if I figure them with a Ronchi screen right against an actual star image. I'm thinking of using a time exposure with my digital camera with a Foucault test of a star image to integrate atmospheric turbulence and thereby get a final result with a Foucault test. And when the Ronchi bands are straight on a star image, or when the mirror and the whole optical system darkens evenly all over under the test with the Foucault test and the digital camera on a star image and the time exposure, then the optical system is perfect. There's no spherical aberration after that. So I've got lots of possibilities. I don't have to get this primary mirror deadly accurate is what I'm saying. I can compensate hopefully with a Cassegrainian secondary if I have to. So here I'm going to start this process over again. This time I'm going to try and do it a little bit more carefully and less for demonstration purposes. Oops, the wrong way again. I'm lifting up a little as I rotate it back into position. You may have noticed that. To try and keep it from digging into the edge as I move it back. Digging into the mirror, that soft pitch from digging into the mirror's edge. You notice I'm working my way outward instead of inward when I do the strokes too for that very purpose. I think I'll just go around a little further this time for a laugh. Trying to lift up a little as I work. These tabs make that easier. As I move back, I should say, not right now. I'm getting confused because I'm old and senile. There. Some of you may have noticed that my strokes are rather irregular and crude. They're not really all that precise. At this stage, it doesn't matter. The X in the center that I put there helps a great deal to judge where I'm working, where the pressure is going. By the way, if you're using the edge of the mirror as a localized tool, like I showed you with accented pressure to work on a high zone, you have to remember to shift it back and forth a little bit to make sure that you don't dig a gouge where you don't want to. Well, it's some kind of a particle there I just moved. I don't know what it was. You understand what I'm saying? See how I'm zigzagging back and forth slightly? I'm not working with the tool in exactly the same spot. You have to remember to shift back and forth a little bit while you're working. Side to side, I should say, not back and forth. That's the strokes. Now the next one will obviously be due west, which is that way. Okay, so it's getting a little dry, and I think I should let the mirror just cold press for a few minutes, so I'm going to add a little bit of polishing agent. I find I can decenter the thing a little without overlapping the edge too much and still put polishing agent on. Just notice that. So I think I'll do it that way. I just kind of dab it, not rub it. So I've gone around 2 revolutions now around the mirror with the mirror with using that method I'm using right now, by the way, is on page 97 of How to Make a Telescope by Jean Texereau. The method I'm using is method C stroke 2. And when I was polishing with the edge of the mirror, the tool, right over the center of the mirror with accented pressure, that is method C stroke 1. If you want to look it up, I think it's page 97 of the hardbound cover of How to Make a Telescope by Jean Texereau. Okay, it does tend to turn the edge, though. That's one of the problems with that method. It did that on my 12-inch, and it's doing it on this one too, according to what I've seen. But anyway, I'll see if that adds enough moisture. Yes, indeed, it spreads around pretty well. So I'm just going to let that kind of sit and move it a bit. Maybe use a couple of short strokes on it, just to kind of make sure the tool is broken in a bit. This short strokes, right now I'm not trying to be carefully parabolizing it, so these short strokes will probably blend any slight amount of micro ripple near the center of the mirror that have caused by those strokes with using the pressure on the narrow part of the edge of the tool. So hopefully, I think I'm being a little bit more fussy than necessary, but I'm doing it that way anyway. So I've used with stroke C number 1 and stroke C number 2, I've already completed 2 circuits around the mirror. Two circuits have been done so far. And if I don't complete a circuit somehow at the end, that's not a good thing. You have to complete a full turn, like of each polishing method, obviously, so that you won't get astigmatism by not polishing in one spot. You might say that if I don't do it all the way around, it'll be a short circuit. Sorry to do that to you, but it just came into my mind. I'll let it cold press for a little longer, maybe give it some pressure, and then I'll start on the other side again. I'll give you an example. Let's say that there's a high zone according to the Foucault test, right about here. Right in that area, about, say, this sort of blends upward a little and then down. So I've got like a raised zone coming up down to a slightly turned edge. All you have to do is put a little bit of pressure. I'll just do it very, very gently, just in one spot, just very briefly to show you. Let's say the spot is right about here. You start right about, say, here, and push down on that hand, the right hand, lift up with the left, and just use a little bit of pressure on that spot. See, like that. Back and forth, and then work your way around. And that'll remove the glass in the high zone all the way around. And by going in and out, like zigzagging a little bit, like this, starting, not just doing it on the spot, but zigzagging it a bit like that, you spread the area polishing out a bit so that you're not digging a groove, gouging out a groove next to the high spot. You're trying to remove the high spot in a smooth, even manner. By the way, if you end up with an irregular surface from doing that, all you have to do is polish it well with 1/3 diameter strokes to get it back to a sphere. If you end up with an ugly groove. I did that on Tom English's mirror. So it worked out fine. It was almost perfectly parabolized at the end of that, just by accident. It was amazing. There was a high zone near the edge that I planed off a little bit that was virtually perfect. Okay, I think that's probably cold pressed enough for now, for demonstration purposes anyway. Let's give it a bit more. Now I'm starting out due west with this method again. So I'll just wiggle this over here. It's probably drying out a little bit now. I probably should add a little bit more fluid to it, but this will be good enough for now. There. Whoops. I'm used to rotating the mirror the other way, the tool the other way. So you have to think about what you're doing when you're doing this. Make sure you don't add any pressure to either hand when you do it, just to let the natural weight of the tool as much as possible do the work. That's the way I like to think of it. Except I tend to lift up a little bit when I turn it back like that. I think carpenters back in the old days used to have two-handed planes they used to use. And this is very similar to that idea, sort of like a two-handed plane. By the way, if you read Texrell's book, he gives a mathematical method, a very easy one, of finding out where any high spot is that you can plane off. You obviously can't add glass to a low spot. You have to plane off the high spots. And he gives a mathematical method of interpreting the surface that tells you where the high zones, the high rings are on the surface of your mirror. I shouldn't have left that there so long. I'll rotate it a bit more. Now this is 3 revolutions, right? Yeah. 3 times around the mirror. Getting a little bit stiff. A very interesting method of interpreting the Coude mask readings to find out where the high areas are that have to be planed off. In this case, the edge area is very easy to see, but some of them are a little bit more tricky, especially as you start getting toward the end of the figuring of the paraboloid. And actually, for a faint high zone, all you need is 1 or 2 circuits around the mirror. You don't need to go around 10 times, so you'll take a huge gouge. Just once or twice, each figuring step only needs 1 or 2 circuits of the mirror, like 1 or 2 revolutions around the mirror, like I'm doing now, is plenty when you're removing a faint high spot, a very faint high spot that barely shows.